We have discussed nomenclature, isomerism, preparation and physical properties of alkanes in the previous videos. In this video, we will do the chemical properties of alkanes. Alkanes are unreacted towards most of the reagents. That is why it is called as paraffins. Para means little, affin means affinity. So these alkanes, they have little affinity towards most of the reagents. But under favorable conditions, these alkanes will react with some of the reagents. We will discuss one by one in this video. First, these alkanes will undergo combustion reaction. So combustion is the reaction between the substance and oxygen. That means the substance gets ignited in oxygen and it will produce heat and light along with the products. So the substance gets ignited in oxygen with the evolution of heat and light, usually in the form of flames. So for example, you can have this one. This is a cooking gas which gets ignited in oxygen to produce heat and light, usually in this form of flame. So that is a very good example for combustion reaction. These alkanes also undergo this type of combustion reaction. For example, you take CH4, methane. This will get reacted with oxygen, that is a sufficient amount of oxygen, and gets ignited and to form CO2, that is carbon dioxide, and H2O, that is water, with the evolution of heat. So we balance the equation. We have 4 hydrogen on the reactant side, so you put 2 here, and then here we have now 4 oxygen on the product side, so you write 2 here. Now this methane gets ignited in sufficient amount of oxygen to form carbon dioxide and water with the evolution of heat and light. So this is we call it as combustion reaction. So you can write like this. This is CH4, that is methane in structure, tetrahedral structure, then with oxygen, 2 molecules of oxygen treated and gets ignited to form CO2, carbon dioxide and water. But when methane treated with insufficient amount of oxygen, it will produce carbon monoxide and water. So you balance the equation, you put 2 here, and so hydrogen will become 8, you put 4 here, and now oxygen here, carbon 2, so you put 2 here. Now oxygen 6, so you put 3 here. So when methane is treated with insufficient amount of oxygen, it will produce carbon monoxide. Again, when methane treated with insufficient amount of oxygen, it will produce carbon and water. So balance the equation here, 4 hydrogen, so you put 2 here. Now you have balanced the equation. When methane is treated with insufficient amount of oxygen, you are getting carbon monoxide and carbon. So that is why methane should not be treated with insufficient amount of oxygen due to these dangerous substances, carbon monoxide and carbon. So it should be ignited only in the presence of sufficient amount of oxygen to form carbon dioxide and water. So this is about the combustion reaction. Next we will go to reaction with steam. So you take methane on treatment with water, you take it in the form of gas. That is what we call it as steam. So methane should also be taken in the form of gas. So when it is treated in the presence of nickel at 2273 Kelvin, it will form carbon monoxide and hydrogen gas. So you are getting carbon monoxide gas and hydrogen gas. And this mixture, carbon monoxide and hydrogen gas, what we call it as water gas. So methane on treatment with steam, when it is heated to 1273 Kelvin in the presence of nickel, we are getting water gas as the product. Next we will go to pyrolysis. Pyro means fire or heat or temperature. Lysis means breaking down. So when you supply heat or temperature, the substance breaks down to form the products. So what is pyrolysis? Pyrolysis is the thermal decomposition in the absence of air to form lower alkanes and hydrogen in the case of alkanes. So here the substance undergoes thermal decomposition to form lower alkanes and hydrogen. Here the substance should be heated only in the absence of air. So thermal means heat is given in the absence of air. Decomposition means breaking in the absence of air. So the substance is heated in the absence of air so that the substance breaks to form lower alkanes, alkenes and hydrogen. So that is what we call it as pyrolysis. Pyrolysis we have two types. They are dehydrogenation and cracking. Dehydrogenation, from the name itself we can understand that there is a removal of hydrogen. Dehydrogenation. So here in this case there is a breaking of CH bond only. But in cracking we have the breaking of both CH as well as CC bond. So that is the main difference between dehydrogenation and cracking. In both the cases we are going to heat the substance in the absence of air. But here we have only the breaking of CH bond. Here we have breaking of CH as well as CC bond. Now here in dehydrogenation you are getting alkene alone. But here in cracking we are getting both lower alkanes as well as alkanes. So in dehydrogenation, when the substance is heated in the absence of air, there is a breaking of CH bond to form an alkane. In cracking, the substance is heated in the absence of air so that it undergoes the breaking of CH as well as CC bond to form both lower alkanes as well as alkanes. So we will see one example. So you take CH3, CH2, CH3. So this is propane. When it is heated in the absence of air, it undergoes pyrolysis. There is a breaking of CH as well as CC bond. So in the first case, we are getting hydrogen. That means there is a removal of hydrogen from this side and there is a removal of hydrogen from this side. So there is a hydrogen gas is removed. So you will be getting CH3, then CH, one hydrogen is removed. Then here you will be getting CH2. So you are getting CH3, CH, double bond CH2. Since there is a removal of hydrogen here from this carbon as well as from this carbon, there is one hydrogen removed. So we are getting a double bond. So plus hydrogen. So this is what we call it as propane. We are getting an alkane. So here in this case there is a removal of hydrogen. So there is a breaking of CH bond taking place. There is a removal of hydrogen. So it is called as dehydrogenation. So here also we are heating this propane in the absence of air so that it undergoes dehydrogenation. That means there is a breaking of CH bond from the second as well as the third carbon. So we are getting a double bond between second and the third carbon with the removal of hydrogen. So we are getting the product as propane and alkene is formed. Now in the other case, there is a breaking of here, that is this CC carbon is broken down. So you are getting a product with two carbon, that is CH2 double bond CH2. That means there is a removal of hydrogen from here also. So there is a CH bond breakage taking place here and here there is a CC bond breaking taking place. That is why we are getting CH2 then double bond CH2. So from here one hydrogen is removed. That will be taking place only through breaking of CH bond. So CH3 will become CH2. Then single bond will become double bond and then CH2. Then you are getting this CH3 will form CH4. So you are getting an ethene as well as methane. Here what is taking place? The breaking of CH as well as CC bond. So this two carbon they will combine and so you are getting ethane and then this CH3 will become CH4. So you are getting ethene and methane. So this is what we call it as cracking. So in cracking we are getting a lower alkane and alkane. Lower alkane is methane. Here we have an alkane with 3 carbon, but we are getting an alkane with 1 carbon. So that is what we call it as lower alkane. And then alkene is ethene. So this is what we call it as cracking. So in cracking we are getting an alkene and lower alkane due to the breaking of CH as well as CC bond. Now in dehydrogenation we are getting only alkane because there is a breaking of only CH bond alone. So this is what we call it as pyrolysis. Next video we will do the remaining chemical properties. Thank you for watching.